Okay, identifying proportional and non-proportional relationships in graphs. I have a table here and it says, does the following table represent a proportional relationship? You should be able to do this because you've been working on this. So go ahead and take a minute, pause the video, see if you can figure it out. I want you to copy the table down, copy the graph down, and then figure out if it's a proportional relationship. Pause here. Okay. Hopefully you realize that no, it does not form a proportional relationship. When you're looking, you can't figure out what you multiply 2 by to get 3. So hopefully you remember you could just do this. 3 over 2, and that's equal to 1.5. And then 5 over 4, what I'm doing is taking the numbers from my table here. That's equal to 1.25. Well, right there, that tells you that it's not proportional. But I'll do one more just to make you happy. 9 over 8, this is 1.125. All right, it's not proportional because this is not the same value. We are not getting the same constant every time, that k value. So my answer would be no. All right, great. Well, we know that, but how would I be able to tell if I graph this information? Well, let's do it, shall we? Now, you got to remember how to graph, because that's kind of important. First of all, this is your x-axis, the horizontal. Your vertical is the y-axis. This is nice because in the problem, it's given to you, your x and your y. It won't always be given to you, though, and it does matter which one goes on which. The horizontal axis, or the x-axis, is considered your independent variable, and the y is the dependent variable. What that means is your y values, they depend on whatever you have for your x value. So, for example, candy bars is what goes down here. Candy bars sold. I'm just going to write candy bars. How much money you receive depends on how many you sell. So that's why y is considered dependent and x is independent. So if it wasn't listed, that's how you would have to graph it. Over here we have money. And then I'm going to write my intervals for every 2. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. And what kind of graph would I have if I didn't have a title? Candy bar sales. Okay, now I'm going to graph. Remember that you always start at this point here, which is called the origin. And I'm going to go 2 to the right on x and 3 up on the y. So 2 to the right and 1, 2, 3 up and make a dot. That represents this right here. Then I'm going to do 4 is next, 5. So I'll go to the right. Again, start from the origin. 4 to the right and 5 up. There's my point. Then I'm going to go 8 over and 9 up for my next point. Right there. And then my last one is 12 over and 12 up. Right there. All right, now I'm going to change my pen. If I were to graph or connect these dots, it would be kind of like this. And then it goes, it slopes over a little bit. Okay? Now, if I want to determine, is this proportional? You would say no. And then how do you know? You're saying, well, how, Mr. Jones? How? Well, it's very easy. There are 2 things that need to exist in a graph in order for it to be or represent a proportional relationship. First of all, it has to be a straight line. Okay? This one's not straight. It started to, and then it kind of curved off at the end. And, yes, it is and, it has to go through the origin. Go through origin. So those 2 things need to exist to represent a proportional relationship. A straight line and go through the origin. And if you look, this one didn't start at the origin, but if you can continue it and it looks like it would, then it would represent a proportional relationship, and it doesn't. But either one of those things would be enough to show that it's not proportional. So if I had a perfectly straight line, but it didn't go through the origin, if I extended the data, then it's not proportional. So let's take this exact same table, and now, whoa, went too far. And now what I want you to do is try and make the table proportional, And then what I want you to do is graph it, and you'll see that you have a straight line that goes through the origin. Trust me, I know what I'm talking about. Okay, pause the video, fill out the table, graph the graph, and here, just to kind of help you, this is what I'm going to have, so your graph will match my graph. Okay? It doesn't matter what you pick for X there. It's independent, remember? I'm just trying to spread out my points so I get a nicer graph. That's why I went 2, 4, 8. Now, what am I doing 2, 4, 8? What am I, crazy? I'm going to go 2, 4, 6, 8. That's better. 2, 4, 6, 8 there. And that just spreads my data out a little bit, okay? So go ahead and fill out the chart and then graph it. Pause the video now. Okay. Hopefully you remember, all right, the 3 over 2, my k factor is 1.5. So in other words, I'm going to take my x value and I'm going to multiply by 1.5 to get my y value. So if I took 4 times 1.5, I would get 6. 6 times 1.5, I would get 9. 8 times 1.5, I'd get 12. Now, this should be proportional because I used a constant value, the k, for each one in the table. Let's graph it and check, shall we? All right, first one is 2, 3. So I go over 2, up to 3. Starting just like the last one. Then I go 4, 6. 4, 6. And I go 6 and up to 9. Ooh, it's looking better. And then 8. And up to 12. I'm going to change my pen to a nice red one again. If I connect these dots, look at this, look at this. It is a straight line, well, the best straight line I can draw. A straight line that goes through the origin. And it shows that, yes, this is proportional. Straight line goes through the origin. Goodbye, my friends.